Okay, let's go ahead and begin with a speed drill today. Turn in your practice exercise and speed drill booklets to page 3. Page 3, and we're going to go ahead and do speed drill number 6. Speed drill number 6. So pencil at the ready, everything else away. Speed drill 6. And we are ready to go, and you may begin. Notice it's an addition box. You're not multiplying these big numbers, just adding them. The easiest one's first. We should be halfway. Stop. All right, put your pencil away and take out a pen. Put your pencil away and take out a pen. So pencils off your desks, pens out. And these are just 2 points apiece. The good news when there's that many answers. I'm going to go across each row. I'm going to read each answer once, so listen carefully. And if you miss one, just put an X through it or a line through it. And at the end of each row, I'll have you keep track like we did with the multiplication box. All right, going across the top row that begins with the 19. 64, 43, 100, 31, 58, 35, 34, 61, 28, 92, 56, 29. I figured the total number wrong on the top row right off the side, hopefully minus 0. Next row, beginning with the 32, 77, 56, 113, 44, 71, 48, 47, 74, 41, 105, 69, 42. Next row beginning with the 74. 119, 98, 155, 86, 113, 90, 89, 116, 83, 147, 111, 84. That's the row I would have done last if you go row by row. Definitely would have done that one last. And the bottom row, beginning with the 28, 73, 52, 109, 40, 67, 44, 43, 70, 37, 101, 65, 38. All right, figure the total number incorrect, multiply that by 2, and subtract that from 100. And then if you would flip back to where it says speed drill 6 on the speed drill score page, and write your score in the spot. Speed drill 6. All right, this was a little bit of a harder one. How many A's do we have? Any A's? All right, Lana got an A. B's? No, okay. Real quick, strategy tip, okay? The column of the 10 is where I would have started. Anytime I see 10, that's easy, either multiplying or adding, right? But you notice there's another column not too far that has 9. Well, if I just subtract 1 from everything I just wrote down, I have the 9 column, right? And then I see the 15 and 16, get either one, whichever one you want, and the other one either subtract 1 or add 1, you got the other one because they're right next to each other. So there's little things like that you could do. If you go across the row, there's one little tip I guess I could give you. If you do the 32 row, 28 is 4 less, right? So basically you just subtract 4 from all the numbers you just wrote down. That's probably going to be easier than trying to add a 28. Does that make sense? So little strategy things you can do to speed up your work and to try to get done faster. But again, that's the lazy mathematician. They say to do this problem. I'm like, what's an easier way to do it? What's a faster way to do it? And that's the laziness coming out. But anyway, things like that you can always look for. And of course, there's really elaborate ones if you want to get real detailed. I see a 39, and over here is a 37. So if you get 1, just subtract or add 2. I mean, I guess that works as well. It depends on how nitty-gritty you want to get with this. But all kinds of little things with boxes like this you could do to speed up your work. Any questions? All right, let me go and collect those from you. And if you would, while I'm collecting them, I want you to turn in your books to do page 55 to 56, the homework section, numbers 1 through 6. Practicing with some percents. Page 55 to 56, the homework section, numbers 1 through 6. A few minutes to work on those. I thought if there's one that's going to mess up her perfect streak, it's going to be this one because it's just hard. And you're still perfect. Wow. Great job. That's incredible. finishing up in the next minute or two. Pencils down, even if you're not finished yet with these, but I do want to go ahead and go over these for sake of time. Number one, a sports store offered 30% off a pair of $150 pair of skis. What's the amount of discount and what's the sale price? No sense taking a shortcut here because they asked for both parts. What's the amount of discount, Scott?
$45.
$45. So what's the sale price, Joshua?
$105.
$105. Sorry, I threw you off there, Scott. Number two, Bradley was buying a new jacket that was $48, but he had a coupon for 20% off the original price. How much did Bradley pay for the jacket? Here we could either go the shortcut or the other way around, doesn't matter which. Lana, how much did he pay before tax?
I don't know. I didn't, I tried the shortcut way, but I didn't.
So what did you try to do?
I tried to take 20% of 48 and then
Good. So what did you get?
Got, for my final answer?
Yeah.
460. I don't know how to.
So you said we take $48. This is what's on the tag, right? And you said 20% off. So you found 20% of 48, correct? Which means you multiplied by 0.2. Okay. And 2 times 8. And 2 times 4 plus 1? 9. And there's 1 decimal, so that means $9.60, right?
Oh.
That's how much off, right? 20% off. So that means we're going to subtract $48 minus $9.60. And that should have given us our answer, Joshua.
$30.
How much?
30. Yeah, I think
No. $38.40 is what we should have had here. $38.40.
I had that. I was just on the wrong question.
Oh. Sorry, okay, $38.40 is what Joshua says he had, just looking at the wrong question there. $38.40 is what we should have had. Lana, does that make sense now? And again, guys, the shortcut you could have used to just say, hey, if he's going to save 20%, what percent does he have to pay? 80%. And then we bypass some of the extra work. Number 3, a computer store sold 25 computers last week. This week, they sold 20% more. How many did the store sell this week? Joshua?
That's 30.
That's the 30. There we go. 30 computers. Again, one of 2 ways. 20% more is 120%. So multiply by 1.20 or 1.2. Right? That times the 25. Or you could go ahead and find 20% of 25, then being 5. Add that to the 25 computers they've been selling to get the 30 computers. A couple ways we could have gotten that. Number 4, population in a small town was only 2,500 people. That is a very small town. After a new shopping complex was completed, the town's population grew by 32%. What was the population after the growth? Welcome back to Lana.
3,300.
Very good, 3,300 people. Well, on the next one, number 5, finding percent of change. What's the formula? It's not much of a formula, but what's the formula for percent of change, class?
Change over.
Change over original. Race car driver drove a warm-up lap around the track in 28 seconds. Then he drove a second lap around the track in 21 seconds. What was the percent of change, Scott?
25% decrease.
Good, 25% decrease. Now, decrease in time, increase in speed. So you could almost argue either one of those, but since we're specifically looking at time, we'd say decrease, exactly right. Again, the change was 7, the original was 28, 7/28 is a fourth, which is 25%. Number 6, a local farmer started the year with 56 farm animals. At the end of the year, the farmer had 63 farm animals. What was the percent of change, Joshua?
12.5% increase.
Good, 12.5%, that is definitely increase. Any questions on 1 through 6? We looked at a couple of them. Any questions though on ones we did not go over? You said I didn't get that answer, I'm not sure how to work that.
Wait, 6 was 12.5%?
12.5%. The change was 7 farm animals, right? From 56 to 63 is a change of 7. He had started with 56 animals. When you reduce that down, it gives you 1/8.125. So 12.5 or 12.5%. And since he went up, of course, we'd say that's increase. Okay, good. Any other questions? Any other questions on this? All right, well, we are going to transition out of percents and all that stuff into a new unit. So I want you to turn over to page 60. Page 60. Now, you 3 have the benefit of having been here at least a couple of years. Students who are new have a hard time with this. So if you're watching and you've not done a Beckett in years, plural past, this could be a challenging section for you. You need to recognize that you're going to have to spend some time studying before you're going to get to the level where the students in my class are at. For you guys, though, this unit should not be too challenging because we're going to talk about measures. I mean, this is practical, nitty-gritty math you're going to use your whole life. Much of it you use already on a fairly regular basis. Now, real quick word here. As far as measurement systems, you've always heard of 2 measurement systems. The English system and the metric system, correct? This is what you're familiar with, English and metric. The reason we call the English system is because the English were the ones who used it. But the English no longer use it. Those in Great Britain, those in England now use the metric system like everyone else in the world. In fact, there's only one place that uses the English system. And that, of course, would be us in the good US of A. We refuse to comply with what everyone else in the world is doing. We are not going metric. We like our miles. We don't want kilos as we're driving down the road. We like measuring things in pounds. What is this kilogram nonsense? You know, we like measuring our height in feet instead of meters and centimeters and all that nonsense. We like what we use, even if the people who came up with it have ditched it. So really, truly, nowadays, the English system isn't called the English system anymore. It's referred to most of the time as the US Customary System. Okay, so just so you're familiar, we're going to use that term now because that's the modern term, is the US Customary System. The metric system, we're still going to refer to as the metric system, and it's based off the meter. But in science, you'll see this notation, SI. It's French for Système International, which is the international system, what everybody uses. So SI and metric really pretty much mean the same thing. We're going to talk about metric later. For now, I just want to talk about US customary measures. And you see a table there. Pretty much all of these you should already know from having been here in the past. Okay, Lana especially. I mean, you've been here since K4?
K5.
K5? Okay, so you've been here since K5. You know these like the back of your hand. Josh, you've been here a couple years. Should have these down pretty well by now. Scott, you've been here a few years. Should have these down pretty well. A foot, 12 inches. Foot used to be the length of a foot. Now, everyone's foot's different. Lana's foot is not going to be the same as my foot. Definitely not going to be the same as Scott's feet. Oh my. So anyway, I don't even know if he has big feet. I just like picking on Scott. But the foot has been relegated to 12 inches, where an inch used to be the thickness of a man's thumb. Mine is slightly less than an inch. I have skinny thumbs. Maybe somebody who has really fat thumbs would have a bigger inch. So again, these are all based on body part measurements at one point. They've kind of been condensed. A yard used to be a man's stride. Well, now it's 3 feet. Okay, so 3 feet. And again, that's a rough approximation. A yard then would have to be 36 inches, since a foot is 12 inches and a yard is 3 feet. The mile, 5,280 feet. That's a number you're going to need to know for science classes in the future, by the way. And because there's 3 feet to a yard, then it takes 1,760 yards for a mile. So some different measurements there. Again, all of those should be familiar to you guys. If you're watching on the video, though, and you're saying, oh man, I don't know that one, mark the ones you don't know. Maybe put a star next to them, what have you. Maybe you're going to need to make some separate flashcards for yourself. But mark the ones that you're not familiar with so that you can go back and memorize them. Maybe you know there's 12 inches in a foot. You've been using a ruler your whole life. No big deal. But maybe you didn't know there were 36 inches in a yard. Okay, so then do what you need to learn those. Some of the ones that you guys might be less familiar with even are the teaspoons and things of that nature. So a tablespoon, this is great for cooking, by the way. And guys can cook, just for the record. I cook fairly well. Breakfast food mainly. I like breakfast. Bacon and sausage and pancakes and hash browns and grits and scrambled eggs and omelets and French toast. Just making you guys hungry now? You just had lunch, so you shouldn't be too hungry. But man, I love cooking breakfast. But it's hard to cook if you don't know how things work. There are 3 teaspoons in a tablespoon. So you got to make sure you know that one. That's a less commonly known one. A cup is 8 fluid ounces. You see that at the bottom, or actually that's not on the bottom. Oh, it's in capacity on the next one. A cup is 8 fluid ounces. It takes 2 cups to make a pint. So you see that a pint would be 16 fluid ounces. A gallon, 4 quarts, where a quart is 2 pints. Okay, so the progression here, getting from small to large, you got the cup, and then if you have 2 of those, now we're up to a pint. You have 2 pints, we're up to a quart, and then it takes 4 of those quarts to make a gallon. It's rough perspective there, but cup, double it, pint, double that, quart, quadruple that to get your gallon. A fluid ounce is 2 tablespoons. That might be a new one for you, by the way. You may not have learned that one in the past. A fluid ounce is 2 tablespoons. So you may need to put a star next to that one. Bushel, for dry measurements, would be 4 pecks. You sometimes hear about a bushel of apples or a bushel basket. That would be 4 pecks, where a peck is 8 quarts of a dry substance. Okay, so those are some that might be newer for you as well. A bushel is 4 pecks. A peck is 8 quarts. Again, you have to memorize these. There's no easy way for me to teach them. You just have to know them. Where again, you've been here since K5, you pretty much know most of these, if not all of them. Newer or never seen them at all. Man, you got a lot of work to do. And I wish there were a way to sugarcoat and say, you're going to be fine. No, you're going to have to study. It's going to be hard. Okay, so you better memorize them. Hey, you deserve for me to be honest, right? You don't want me to lie to people. A pound, 16 ounces. We should be good with that one. We use pounds all the time. And then ton, we shouldn't use all the time, but it's an easy number to remember. It's 2,000 pounds. So those are your U.S. customary measures of length, capacity, which means how much something holds, and weight. Time is interesting. Time, I was actually talking to Chloe about this the other day. She was asking about different things, and I was telling her that the moon goes around the earth. She said, really? Yeah, it does. And the time it takes to go all the way around once, and the way in which we see the moon, that's where month comes from, moon. She's like, whoa, months are based on the moon cycles. Yes, now roughly, okay, we've kind of adapted it. They're not based purely on moon cycles anymore, but they used to be. The year, of course, based on how long the sun, or the earth rather, goes around the sun. The day and how long it takes the earth to revolve on the axis, and things of that nature. The week, though, interestingly, has nothing to do with moon, sun, stars, earth, anything. It's what God came up with, right? And it's interesting, in a society that doesn't want to admit the existence of a God, they'll still use the week. And, you know, the weekends, they like their weekends. Yeah, you can thank God for that, even though you don't want to acknowledge his existence. In fact, you might have heard there was a group of people that decided, we don't want a 7-day week, because that does point to a God. We're going to abolish the 7-day week. We're going to do a 10-day week. 10 seems like a better number to us. We're going to do a 10-day week. And this group of people tried to do a 10-day week with weekends still, right? 2-day weekend, 8 days of work instead of 5 days of work and 2-day weekend. And the animals started dying from the overwork. Funny, the animals need 5 on, 2 off, or 6 on, 1 off, depending on how you work them. And have you heard about that? When was that? Back in the 1700s, the French Revolution. When the French Revolution happened, the people who overthrew the monarchy decided to reinvent the week, and they figured out pretty quick that doesn't work. God knew what he was doing, even if we don't want to acknowledge his existence. But anyway, so to the units of time, these we should be good with. Even if you're not familiar with these from the past, you use these all the time, right? A minute is 60 seconds. We got that. Hour, 60 minutes. A day is 24 hours. Week is 7 days. Year, this one might be new for you if you're new to this. A year is approximately 52 weeks. And a year is also 365 days. I think the 365 everyone should be good with, but again, new students, 52 weeks in a year might be a new number for you. Of course, a leap year is 366 days. How often do we have leap years? Every 4 years. Reason for this, it's approximately 365 and a quarter days to get around the sun once. But let's be honest, quarter days are awkward. So the thought is if there's quarter days every 4 years, that would make a whole day. But it's not exactly 365 and a quarter. It's really, really close. It's like 365 days, 5 hours, 56 minutes. So we're like 4 minutes shy. That doesn't make a big deal, but it adds up over time. So there's even a system built in to correct that. Every 100 years, you know all numbers ending in 00 are divisible by 4, right? So theoretically, all 00 years should be leap years. But to compensate for the 4 minutes every year that we don't quite make it, if the number is not divisible by 400, which this one's not, right? Because 19 isn't divisible by 4, not a leap year. 1896, leap year. 1904, leap year. But they went 8 years in between. They didn't count 1900. They didn't count 1800 as a leap year. 1700, not a leap year. 1600 was, because that's divisible by 400. 2000, is that divisible by 400, class? Yeah, this is before y'all were born at this point. Man, this makes me feel old. But this was a leap year because it's divisible by 400, right? But 2100, if y'all are alive for that, you'd be really, really old too. I'll be dead. But 2100 will not be a leap year, right? Because they're trying to accommodate for those 4 minutes off or so each year. A year is 12 months. I think everybody knows that. A decade is 10 years. I think that's an often enough used term. I think decade should be fine for you. A score of years. We don't use that term very often, but a score is 20. You'll see that term in the Bible quite a bit. Score meaning 20. A century is 100 years. I think that's pretty easy. Cent, 100 cents in a dollar, 100 years in a century. And a millennium, 1,000 years. And most of these measures of time you see at the top of the page are pretty straightforward. By the way, measures of time are not US customary. They're across all fields. So metric, US customary, we all use the same measures of time. Any questions on the different measures? All right. You good on all of those? Is the 2 tablespoons in a fluid ounce new to you, or you knew that one already?
That one's the only.
That's the only new one. Okay, so make sure we commit that one to memory. Then 2 tablespoons in a fluid ounce. Joshua, any of those besides the 2 tablespoons in the fluid ounce that you would say, ooh, I didn't know that one? Or do you feel pretty comfortable? You're probably the newest one with only 2 years here.
There's nothing else.
All right, everything else, you're like, I've memorized it already. I worked really hard when I first came to learn all these. You remember how hard you had to work to memorize all these and catch up? I think you were in 6th grade, right, when you came? I'm sure it took a lot of work memorizing it all. Scott, you've been here a few years. You're the same boat with Josh. You know all of these except maybe the 2 tablespoons in the fluid ounce. Okay, excellent. Well, let's go ahead and drill over these. We'll drill these in each of our lessons coming up. But for now, we'll just kind of go through as a class. We'll make competition out of it in future lessons. Just call out the number. 1,000 in a millennium. 100 years in the century. 20 years in the score. 10 in the decade.
12.
Good, 12 months to a year.
366.
Good, 366 days to the leap year. 365 to the normal year.
7. Wait, 52.
Good, approximately, he saw week, he's like 7. No, 52, approximately 52 weeks in a year. Technically 52 weeks, 1 day or 2 days, depending on whether it's a leap year, but very close to 52 weeks.
7.
Good, which means, by the way, a quarter would be 13 weeks, right? A quarter of the year would be 13 weeks at a time, just throwing that thought out there. Good, week 7 days.
24.
24 hours in a day.
60.
60 minutes in an hour.
60.
60 seconds in a minute.
2000.
Good, 2,000 pounds in a ton. By the way, pound, that's always a fun one. LB, right? Lubs. 2,000 lubs in a ton. But anyway, yeah, where the LB comes from, I believe it's from the either the French word or the Latin word that meant they used for pound. But anyway, how many ounces?
16.
16 ounces to a pound. Now we get into the harder ones for most students here. 8 quarts, remember, to the peck.
4.
4 pecks to the bushel.
8.
16 fluid ounces to the pint, and only 8 to the cup. Here's the way my mom helped me remember this, because in cooking, she said a pint's a pound, the world around. It rhymed, so I remember it. A pint's a pound, the world around. but a pint is a pound. If you have a pint of water, it's a pound. So this water bottle now 16.9 fluid ounces, but if you drink just a quick swig, then you've got a pound of water. So if you think about it now, you buy the case of the cheap water bottles from Walmart, they come 42 a case. Each bottle's a pound, roughly. So how much are you carrying if there's a pack of 40?
40 pounds.
A little over 40 pounds, right? 40 pounds and then an extra ounce from each one. So that's 40 extra ounces, that's about 2 extra pounds. So about 42 pounds you're carrying in one of those things. But it's always a good thing to think through, right? As far as so if you really wanted to, you're working on, exercise, you're like, I don't have any dumbbells. Grab a bottle of water in each hand and go. Got your pound in each hand. It'll be really warm by the time you're done. Anyway, or empty if there's a hole in it.
2.
Good, 2 tablespoons in the fluid ounce.
4.
4 quarts to the gallon.
2.
2 pints to the quart.
2.
And 2 cups to the pint.
3.
3 teaspoons in that tablespoon.
1,760.
1,760 yards. Right, because remember, a yard is bigger, so there won't take as many of them to make a mile. Whereas for feet,
5,280.
5,280. Yeah, and when you play review games, the number just rolls off the tongue. You get used to shouting it out as fast as you can. 36 inches to the yard, 3 feet to the yard, and 12 inches to the foot. So we'll go through all of these in a review game in the next couple of lessons. We'll continue to practice with those. One of the other things then, again, you all will remember, but new students, this may be new for you, is converting between different measures. To say, okay, well, if I've got this many gallons, how many pints do I have? For instance, supposing you bought, you made lemonade in big gallon jugs, you made several gallons of lemonade, and you're going to sell lemonade at a lemonade stand, you have to have a government permit first, apparently, or else you can get, your things shut down by the police. But anyway, that's America for you. But anyway, I gotta tell you, it's just like, you're shutting down a lemonade stand, really? Come on now. But anyway, lemonade stand, you're like, okay, I got 3 gallons, and I'm going to give pint-sized glasses or cup-sized glasses to people who buy it for 50 cents each. How many of those have I made? So it's good to be able to convert back and forth. Well, let's suppose we wanted to convert 3 gallons, and we wanted to know how many, let's go with how many quarts is that first of all. How many quarts in 3 gallons? Well, 2 rules you need to remember, and you see them there in your textbook on page 61. To convert from a larger unit to a smaller unit, multiply. Or the way we said it in school, you can do the hand motion with me, larger to smaller, multiply. Okay, so hands out for larger to smaller, and keep going and multiply. Okay, and then from smaller to larger. This is where everyone does it different. How did y'all do it? My teacher taught with the scissors, which cut or divide. Smaller to larger, divide. That's how I learned it, but there's no good hand motion. But larger to smaller, multiply works great. So if you just remember it's smaller and larger, it's the other one, okay, which happens to be divide. However you choose to symbolize that. Well, here notice we're going from a large unit gallons to a smaller unit quarts. Larger to smaller class, we multiply. And we multiply by however many of that goes into that, or how many of that goes into that. Well, what's the relationship between quarts and gallons? What's the key number? 4, right? 4 quarts to a gallon. So we multiply by 4, of course we get 12. Now, of course, we can convert the 12 quarts further into pints. Supposing we were going to do a pint-sized glass for everybody. That's a pretty good-sized glass of lemonade there. That should refresh somebody. Well, are we going from larger to smaller, or smaller to larger? Larger to smaller again, right? Going from quarts, which are fairly large, to smaller pints. So again, we're going to multiply. And what's the key number to go from quarts to pints? 2 pints in every quart. Again, that's why you have to have these memorized, which would be 24. So if you're selling pint-sized glasses of lemonade, you're only getting 24 of them. So 3 gallons doesn't go that far, unless, of course, you don't expect to sell a whole lot. Maybe go with smaller cups or whatever, but go from there. Look at the example problem. 48 hours being converted into days. Which is longer, an hour or a day?
Day.
The day is definitely longer. So we're going from hours, that's what I was given, to days, which are bigger. So smaller to larger, divide, because it doesn't lend itself to the hand symbol for multiply. So we're going to divide. So they took the 48 hours, and they divided by, well, how many hours in a day? 24. And it gave them 2 days. Look at the next example. 5 yards is how many feet? Which is bigger, a yard or a foot? Yard. The way I like to remind students, in case they forget, you see the yardstick up there? It's actually a meter stick, but a yard's about the same. See the yardstick up there? Which is bigger, the yardstick or my foot? Answer carefully. The yardstick. Very good answer. All right. Safe answer, right? Yard is bigger. So we're going from yards to feet, larger to smaller, Multiply. So they multiplied by the 3 feet that are in a yard, and that gave them their answer 15 feet. Any questions on converting units? Extra sheets do 1 through 9 at the bottom of page 61. 1 through 9 at the bottom of page 61. If you're new and you're trying to remember what's the conversion unit, what's the special number, you can go back and look at the table for now if you need to. So if this is unfamiliar territory, it's okay to look at the numbers for now. Just start working on committing them to memory as you go, as the days pass. Because in about 3 or 4 lessons, you're going to have these memorized. So begin working now. Don't wait 3 or 4 days. Doing 1 through 9 at the bottom of page 61. Well, let's see what it says. Pie is 2 cups, so it must be bigger to have 2 of them inside. Scott's finished. The rest of you take a little bit longer to finish up. For sake of time, put your pencils down. Let's check our answers here. And Lana, place your pencils down. And let's check our answers. And number one, Lana, what did you get for 198 inches?
16 and a half.
Feet, 16 and a half feet, dividing by 12. Number two, 7,040 yards, Joshua?
4 miles.
Dividing by 1,760. 14 pounds, Scott? 224 ounces, multiplying by 16. 28 pints, Lana?
56 cups.
Good, multiplying by 2. 16 pecks.
4 bushels.
4 bushels, dividing by 4. 8 tons.
16,000.
Pounds, good, 16,000 pounds, multiplying by 2,000. 120 hours, Lana?
5 days.
5 days, divided by 24. 27 tablespoons, how many teaspoons?
243.
Ooh, what did you multiply by?
9.
Yeah, but how many teaspoons are in a tablespoon?
3.
Should have multiplied by 3, Scott, to get 81. Let's go back to Joshua number 9. 11 cups. How many fluid ounces?
I didn't get this.
How many fluid ounces in 1 cup?
8.
8 ounces. So if there's 8 ounces in 1 cup, that means you're going from a large cup to small ounces. You're going to multiply by the 8. 88 fluid ounces. There we go. All right, anyone perfect? You got all 9. All right, any questions? Turn the page. Do numbers 10 through 21. Turn the page. Do numbers 10 through 21.
Lucy.
Gotcha.
Think about another minute and a half or so to get as many done as you can. Finish these out. Alright, for sake of time, we're gonna go ahead and need to stop. Let's see. Scott, you were able to finish all of them. Joshua, how far did you get?
I got to number 17.
Number 17, that's pretty good. And then Lon, you got stuck on one. How far did you get?
I only get to number 14.
Number 14. Okay, so not real far. Tell you what I'm going to do then. I'm going to have you finish those out for homework, and we're going to go over them tomorrow. That'll give you a chance to go ahead and finish them out. So just got a few left to finish. Got a few more to finish, but we'll go ahead and add that onto the homework. Your homework then is to do page 59, numbers 1 through 21. Page 59, numbers 1 through 21. And I want you to finish page 62, numbers 10 through 21. I want you to finish page 62, numbers 10 through 21.
And the homework or no?
No, in the practice section at the top, finish the ones we were just working on. The 10 through 21 we were just doing, just finish those out for homework. So again, Scott's already done with them. Josh has a few, you've got several, but it's okay. We'll go over them tomorrow, and that way we make sure we're good to go. All right. If you're new to this, make sure you spend some time studying. Make some flashcards. Drill yourself. You are dismissed.
59 something.